Esar for this warm welcome and hi to everyone. It's really simply good to see some real faces again. Space exploration is a billion-dollar business. It's the next big thing for the private market. It holds the promise of creating unforeseen business opportunities as well as solving global issues. Big players and visionaries out of the Silicon Valley ecosystem are naturally affiliated with topics like this. Elon Musk, Jeff Bezos. But what about Europe? What about the European optimism we just heard this morning? We have the talent, the creativity, and the power to play an important role to shape this market. More than 230,000 jobs, more than 50 billion worth market for Europe, simply made by old and new economy. The upcoming session is made to simply inspire you how young, talented entrepreneurs with a big vision can reach the stars by co-creating their solutions together with old economy, so-called hidden champions, family-owned businesses. By combining their strength, innovative mindset, and expertise together with agile new companies, we do believe we have an advantage in the European edge. For almost 2 decades, as Helmut just mentioned this morning, we as UnternehmerTUM are working on connecting and empowering entrepreneurs all over Europe. More than 5,000 talents and startups per year. More than 100 companies a year. This is great, but to be honest, it could be better. It's only 1% of companies we're currently reaching. It must be more. This is why we, as UnternehmerTUM, are launching UnternehmerTUM, a new initiative to focus on family-owned businesses by connecting them, nowadays leaders and future gen leaders, to the European innovation ecosystem and to also our friends at DLD. To boost new businesses, to shape the market, but also to unlock, as DLD's motto is, the unexpected. So let's take all together the first small step, like in space. And now I'm handing over to Jennifer. Jennifer is the chief editor of the Innovator, a long-term friend of DLD, and a European by heart, I would say, although she's national American. And she's going to host you the session and give a round of applause to her. Thank you.
Thank you, Christian, for that wonderful introduction to Europe's role in innovation in space. It is my great pleasure to introduce 3 European companies that are each adding something to help forward Europe's role in space. Let me welcome Alexander Gerfer from Würth Elektronik, Daniel Metzler from Isar Aerospace, and Joachim von Schlenk from Schlink Group. They're each going to give a short presentation on how they're participating in space, and immediately following that, we're going to move into an interactive discussion. So let's start with Alexander from Elektronik.
Yeah, thank you very much for having me. So I'm from Würth Elektronik. And we belong to a bigger group, the Würth Group, eventually well known in Germany for screws, nuts, bolts, a very big company, $14 billion company consisting out of roughly now 420 companies around the globe. And the founder's idea was to have small entities, small companies, agile enough to react to customer needs. So our innovations are customer-driven innovations. And we, as Würth Elektronik, we do manufacture electronic components, electromechanical components, used for making hardware. You don't know what hardware is. You have seen the musicians eventually this morning. They are playing their music fully on the hardware around the corner. You use the hardware every day when you use your mobile phone. And we are in these applications, but with a big difference. We make things available. So that's one point. You have heard about the automotive sector now struggling to get semiconductors. There's a big impact now from the COVID pandemic. And I myself did fail I was a startup in the younger years, and we did fail not because of the technology, not because of the business model. We failed because of not getting one single piece of component on the right timing. to going to a contest to win we would won the contest, that's for sure. Also missing these single piece, and that's what we love, is we love hardware. So we make these things, we produce globally. We are locally with the engineers, that's our aim, and the design engineers, to help them to get their hardware design going fast into market. And what we have seen today, we have seen a lot of things like platforms, we've seen it's digital life design. Nothing is possible without the right hardware in behind, and the acceleration of innovation in hardware design, because we have to be energy efficient, we have to go smaller, we have to have not big computers doing the calculations, it has to be small and high speed, and that's all driven by innovations, eventually not seen in the first moment, but what we try to accelerate here. And of course, still searching for talents, loving hardware, not only digital design, also hardware design, which is eminent important for the future growth of ideas also we hear and talk about today.
Thank you very much. Let's now turn to Daniel. Please tell us a little bit about what your company is doing.
Yeah, I'm one of the co-founders and CEO of Isar Aerospace. We build orbital launch vehicles to put small satellites with up to 1,000 kilograms into Earth's orbit. And so we're basically covering the very first part of the entire value chain of the space industry, because all of those birds need to get up in the air, need to get up into orbit, and we're just building a launch vehicle which is way more smaller but more flexible to actually serve those small satellite customers. And when we take a look at the satellites that we've been putting into orbit over the course of the past few years across the entire world, those satellites have been getting smaller and smaller. So a satellite which about 10 years was weighing about a ton, as of today is weighing less than 100 kilograms. Due to innovation, thanks, for example, in the electronics industry, a satellite at the end of the day is nothing less than just electronics. And so when 3 years ago we founded Isar, the goal really was to make sure that those barriers to space can be lowered and that we can really enable a commercial space industry. And so far, we were a spin-off from the Technical University of Munich. We've raised more than $100 million of venture capital so far, and are targeting our first launch to happen roughly mid-next year.
Great, and most of the capital, the 100 million that you raised, came from European investors, correct?
Exactly. So that was actually quite a big challenge, but we're very, very happy to actually have succeeded at that. So the majority of all of our shareholders and investors is European.
Okay, great, thank you. And Joachim, let's turn now to Schlink. Tell us how a 140-year-old family-owned business fits into the space revolution.
Yeah, we are in the value chain much behind these guys, because we are basically producing the materials where your suppliers produce the components. And as you said, our business is quite an old business. Our main products are metal powders and metal foils. And let's say in the space industry, the products we produce are basically for the same application as in all of the other industries where we deliver, in the chemical industry, in the electronics, in the automotive. But there's a difference. I mean, take for example a circuit board, which your rockets carry, of course, and nothing goes without the circuit board for steering the rocket. It's a difference if you build a steering board for a car or for a plane or for a rocket which starts in French Guiana or maybe in Munich. Or I don't know where you build your hub, probably in Norway. Or
Norway.
And then you shoot it up to 270 degrees minus. That's a temperature difference of 300 degrees. So these materials must really, let's say, fulfill totally different properties, and that's basically what we are doing.
And correct me if I'm wrong, but I think the space part of your business is amongst the fastest growing today, is it not?
In certain areas, it's a really fast-growing business. Yeah, I mean it's basically components for which we didn't done for many years, but now it's it's becoming a little bit more mass product due to the mass of satellites which are carried at the moment. Yeah.
So now I'd like to ask you and both Alexander, how do you think that your supply of these very specialized materials that are optimized for space can actually help space innovation, and what kind of companies are you working with as customers?
I think we can help with the experience which we have for many years in this field and adopt very, very quickly in a, let's say, in a technological ecosystems where companies are in Europe close together. The ways are not far with our laboratories which are equipped for these things. So we can adapt quite fast to the customer's needs. So we are very good equipped for that, I would say.
Okay.
We are close. That's okay. Basically where we can help most.
Thank you. Alexander, where's the demand going to come from?
Let's explain it this way. When you look into the what I just said before, semiconductors for automotive, they only do 5% of total sales of a big company like TSMC, but they play a big role and make a big difference now, not getting them into the production line. When we look into the space, when I'm right, it's about, when I look into the projects of Kuiper and Starlink, they want to shoot about 42,000, 48,000 satellites in the end of that into the room, into space. Eventually, that's not even 1% of the total semiconductor usage you would have. And our aim is to say we have the access to these companies like a TSMC, Global Foundries, and we have own design engineers listening to the requests of these guys. What do we have to fulfill to make this rocket working, going up into the space, as well as what is a satellite needing to do to survive 18 or 20 years in space? We cannot go and repair there. So that's where we say we bring our expertise, our talents, which we also have across Europe. Yeah, that's a very interesting thing. Big team in Leuven, so near Brussels. Yeah, we have a team here in Munich. We built a new center even in Freiham, near Munich. We have Berlin, we have Barcelona, we have Valencia. So we have a lot of talents, and putting the right people together, understanding the needs, and then think how can we maintain that we build the right semiconductors. I have a picture eventually on the slides brought with me how a semiconductor looks inside. I'm not sure if we have it on file now, but this is what we do, and we support, and we learn from the customer needs and make it available for them.
Okay, thank you so much, Alexander. And Daniel, let me come back to you. So where do you fit into the competitive landscape? How do you, what you're doing compare with like what SpaceX or Firefly Aerospace or even Arianespace here in Europe?
So our rockets are fairly small, but also the entire way on how we design, on how we build our rockets is completely different. And actually there we take all of those innovations from other industry sectors actually into our build, into our rocket design. So for example, the rocket engines we manufacture, they're completely 3D printed. So the combustion chambers, a lot of the turbopump components, they're all 3D printed, which actually means we can manufacture with the technologies, and really they're starting at the raw material powder, of metal powder. We built those combustion chambers now in about 2 weeks compared to what the established industry has been doing as of today still, which takes them 1.5 years. The exact same product, but we just manufacture it many, many times faster. But those are all topics which you basically have to already take care of in the very design phase of the rocket. So you cannot just at some point switch and say, look, I'm now going to change my entire manufacturing process, the entire supply chain. So once a system is fully proven, you don't change it that easily. Although, again, this is also how we think about our rockets, that we do completely different than the established space industry. We see a rocket more as a development product. I mean, on your phone, you always get constant software updates. Why should a rocket not get constant software updates? I mean, cars even get constant software updates. And actually, when you take a look, for example, on the electronics of a rocket, you would actually think the electronics of a rocket is way more complex than the electronics of a car. But to be honest, the complexity of the rocket's electronics is way less than what's in the cart as of today. It's really just, if it's not 100% necessary, it gets stripped off the rocket. Every single gram of mass that is not really needed to fulfill the purpose of the rocket, that does not go to orbit.
And in terms of your competition with, like, say, SpaceX, the difference, if I understand, is that you carry smaller payloads, and so if you were a player with a small satellite, you might not want to be on a SpaceX mission. Can you
Exactly.
explain?
I mean, so if you build a 500-kilogram satellite and you need to go into space, as of today, you actually need to get what's called a rideshare spot on a rideshare mission with tens or sometimes even hundreds of other customers. But really, taking a 20-ton rocket and putting hundreds of customers on the same rocket actually also means that you're dependent, because if you're not 100% ready right at the right time, or because either a supplier from you might have slipped a bit or a test campaign slipped a bit, then you're actually doomed to either go on to the next rocket. Sometimes you actually may even fail to find the rocket going in the exact orbit that you need to go to. So in that case, those customers always turn to us and say, look, I get to buy the entire rocket. I pay pretty much the same cost per kilogram of satellite, which is what our customers are interested in, but I just get way more flexibility in terms of operations, so that they don't have to wait 2 years, for example, such that a big rocket with a lot of different customers can get to a specific orbit, but we can just offer that very flexibly and say, look, here's customer A going to that orbit, and then 2 weeks later there's customer B going to a completely different orbit, but they're completely decoupled from each other. So those primary customer rights we can really offer also to the small satellite customers.
Thank you. I'd like to ask Christian, are you still around? Can you come back up on stage?
May I add something quickly on because we were talking about the rockets as well as the satellites, because it's right for the rocket eventually it can go more easier, but for the satellite it has to last 18 years. So we have to be sure that the semiconductors we build are radiation hardened, because it's a lot of UVC and other electromagnetic pulses around. So we have to understand really how the satellite is there in the space, and we cannot go there and repair the satellite. It has to be there, it has to last there, it has to be energy efficient, because you have a power eventually of 60 watt going down to the earth, also less than a light bulb today, and you receive still the signal, you still can make broadband internet connection everywhere. And that needs the understanding of what I mentioned, the mission profile. So what does the satellite see when it goes up with the rocket? What does the semiconductor have to fulfill with the other components to be longevity? And that is what we say when we collaborate, and we discuss it, and then we bring it to work, then we speed up. And we should not do, in my perspective, the same failures when we build up the 5G networks, give it all to others, and later complain, yeah, but now it's driven from Chinese manufacturers, let's say it this way. We have it now in our hands to build it up European-wise and steer it from European companies, and not give it again out of our hands and make it possible working here.
Thank you. That's a great point, Alexander, and it's a great segue to what I wanted to ask Christian, because there's a new initiative going on that you are helping spearhead that actually tries to bring together family-owned businesses from Germany and elsewhere in Europe and connect them into the innovation ecosystem to ensure, as Alexander said, that we have European solutions, particularly when we move into this next frontier. So tell us a little bit about that initiative and why you think that Europe can be competitive by harnessing small and medium-sized businesses and family-owned businesses.
Yeah. So although I'm normally emotionally driven, in this case I stick to numbers. I mean, it's pretty easy. At the moment we actually connect roughly less than 1% of companies to that innovation ecosystem. So the impact will be not that good, to be honest. When we take into account that 80% of the companies in Europe are family-owned businesses, when we take into account that 60% of the jobs are driven by family-owned businesses, there is no way out not to include those companies actively in shaping those markets like space. So it's not a space topic, it's a general topic. And this initiative is intended to do, let's say, the same success story, the recipients and ingredients we have for the talent and startup story we just heard this morning, 5 unicorns and many, many more, being adopted, copied to family-owned businesses. And to give it a final, it's actually when you get family business engaged, they are impact and value driven. So once you get them engaged, it's a long-term commitment. And that's what we need. That's a true chance. Thank you.
And I think what we've seen here today, just to end the the session on a positive note is that it's not just startups bringing innovation to the family-owned businesses and the traditional businesses, but traditional businesses like the two we have here on stage bringing innovation to the startups. So thank you all very, very much for an interesting session, and let's please give them a nice round of applause.